For generations, our world has challenged explorers to seek what lies beyond the horizon. Now, the invention of spaceflight is leading us outward to explore a host of alien worlds with vast new territories. Today, we see the sun, moon, and planets with penetrating clarity through the eyes of the intrepid machines blazing a trail for us across the solar system. Their cameras have become our windows onto a bold new adventure. Their discoveries have become our cosmic vistas. There are more than 100 moons in our solar system. The vast majority of them orbit the two largest planets, Jupiter and Saturn. Collectively, they run the gamut from small to large, cold to hot, and quiet to active. Could it be that somewhere in that range of possibilities, we will find a hidden haven for alien life? Most of the moons that orbit Jupiter and Saturn are quite small, but a few are so large and complex they could easily be considered planets. For more than 300 years, there was almost nothing astronomers could say about these intriguing places. Thanks to spaceflight, that's no longer the case. In 1979, Voyager 1 and Voyager 2 sailed past Jupiter's 4 largest moons with their cameras rolling. The pictures they radioed back reveal that each moon has its own distinct character and a range of features unlike anything seen before. The biggest surprise of all was Io, the innermost of the 4 moons. Its rocky surface is a mottled and sulfurous mess. Unlike our moon, there are no craters on Io. It's as though they are being erased by some mysterious agent. The explanation came when Voyager 1 spied something unusual protruding 300 kilometers from one side of Io. It was a fountain of ash spewing from a large volcano. Since that discovery, it's now become clear Io is the most geologically active world in the solar system. Io's surface is one vast lava flow, with more than a dozen active volcanoes towering over the sulfur-rich landscape. The gravitational pull of Jupiter and some of its other large moons creates a tug-of-war inside Io, which generates vast amounts of heat. While this makes for a dynamic surface, it is not particularly hospitable to life. Jupiter's outermost large moon, Callisto, couldn't be more different. Callisto's battered face is saturated with ancient impact craters, suggesting not much has happened here since Callisto formed. But looks can be deceiving. The most recent data suggest there could be a zone of salty water somewhere deep below Callisto's surface of ice and rock. Whether life could survive in such a hidden environment remains an open question. Meanwhile, on Ganymede, we find more obvious signs of a geologically active past. Ganymede is the largest moon in our solar system and one of the strangest looking. Part of its surface is as old as Callisto's, dark and heavily cratered. But the dark areas are fractured by a more recent terrain made up of parallel grooves and ridges. Exactly how these grooves and ridges formed is still a big mystery. It is clear Ganymede has a warmer interior than Callisto. In the past, that warmth may have risen up through Ganymede's interior and forced sections of its surface to drift apart, just like the continents on Earth. Because of its heat, Ganymede's interior has likely separated into layers, starting with an iron-rich core at the center, a surrounding mantle of rock, and a thick layer of ice on top of that. As with Callisto, there is evidence on Ganymede for an ocean of salt water somewhere below the surface. This is exciting news, because the right combination of heat and water may provide the conditions necessary for life on Ganymede. Such life forms would be cut off from the sun and the surface environment. But like the creatures that live around deep sea vents in Earth's oceans, it might survive on chemical energy. This tantalizing possibility won't be tested anytime soon. If Ganymede has an ocean, it's at least 200 kilometers below its frozen surface. A better opportunity for exploring the ocean of another world may exist on Europa. At first glance, Europa seems like the least interesting of Jupiter's moons because its surface is so flat and smooth. Its lack of dramatic relief, like mountains or large craters, might be an indication that water isn't far below. Europa is crisscrossed with a network of cracks that suggest its icy crust has opened up from time to time, letting a watery slush spill out onto the surface. In one area, scientists have found what appear to be icebergs that cracked and floated apart like rafts before the surface refroze. Some of the cracks on Europa have a darker and more reddish hue than the rest of the surface ice. This could mean that the underlying ocean is rich in sulfur compounds and perhaps organic molecules. Indications are that in some places, this ocean may be less than 10 kilometers from the surface, possibly within reach of a future attempt to drill down and explore the marine environment of another world. Today, Europa's ocean is high on the list of locations where scientists are eager to search for alien life. The surfaces of Jupiter's moons may conceal many mysteries. But on Saturn's giant moon, Titan, even the surface is hidden from view. Titan is the only moon in our solar system with a substantial atmosphere, and it shows. When Voyager 1 arrived at Saturn in 1980, it found Titan shrouded by a thick orange haze. This haze is like a photochemical smog produced when sunlight reacts with methane in Titan's atmosphere. It would be a full generation before scientists had their next chance at Titan. When the Cassini mission arrived at Saturn in 2004, it used a high-powered camera equipped with an infrared filter to penetrate the veil of Titan's thick haze. What Cassini found was even stranger than expected. A surface divided into mysterious light and dark regions, resembling ancient coastlines. Cassini also bounced radar signals off of Titan, confirming that the moon's surface is solid, with unusual landforms like ice volcanoes and wind-blown dunes. After several more passes of Titan, Cassini's radar made an even more exciting discovery: a series of dark patches that were perfectly flat, resembling the surfaces of small lakes. Scientists were eager for more direct evidence of potential fluid flow on Titan. They found it in dramatic fashion when Cassini dropped a probe into Titan's cloudy atmosphere. After the probe deployed its parachute and slowly descended, it radioed pictures back to Cassini. As soon as the probe emerged from the clouds, it began to see exciting details that looked suspiciously like they had been carved by a flowing liquid. Then, to everyone's surprise, the probe survived its impact and sent back one final spectacular image. It showed chunks of ice, clearly rounded by fluid flow, like rocks in a stream bed on Earth. On Titan, it's so cold that water is like rock, but methane, which is a gas here on Earth, can rain down from Titan's atmosphere and flow as a liquid over the surface. Methane is a building block for the kinds of complex molecules that led to the emergence of life on Earth. And that means if Titan has an internal heat source, like some of Jupiter's moons, it could also be harboring its own ecosystem deep below the surface. One thing is clear. Titan and Jupiter's moons are no longer sideshows to the planets they orbit. Together, they have become the main motivators in our exploration of the outer solar system. Here on planet Earth, it's easy to take water for granted. Water covers 70% of Earth's surface, and its presence is essential for life as we know it. Farther away, in the dim reaches of the outer solar system, water plays a different role. Around Saturn, water is everywhere. With temperatures near minus 180 degrees Celsius, it's far too cold for water to exist in a liquid state. Here, water remains frozen solid, so solid that it doesn't just cover worlds, it makes worlds. When we get to Saturn, we discover ice is the main ingredient in building moons. In fact, Saturn is surrounded by an entire family of icy moons that the Cassini mission has now revealed in spectacular detail. By exploring these frozen worlds, scientists hope to reveal an ancient story, not just about Saturn, but about the entire outer solar system. This is certainly the case with Phoebe, the first of Saturn's moons that Cassini encountered up close. Just 200 kilometers across, Phoebe is too small and its gravity too weak to pull itself into a sphere. When Cassini sailed past Phoebe, it found a surface rich in carbon, with deep craters exposing layers of bright white ice lying just below. Overall, Phoebe is darker and contains more rock than Saturn's other icy moons. This suggests it did not form near Saturn, but in the Kuiper Belt, beyond Neptune. The objects inhabiting this zone are ancient, the original building blocks of the outer solar system. It now appears Phoebe is an escapee from that region and only later captured by Saturn and turned into a moon. This moon is giving us a sneak preview of what we'll find at much further distances from the Sun. 4 times closer to Saturn and 4 times larger than Phoebe, Iapetus is a very different kind of moon. It is 80% ice, but its most distinctive feature is its strange two-tone shading. While one side of Iapetus is extremely dark, the other is whitish-gray. This color difference also corresponds to a significant temperature difference. On average, the dark side is 15 degrees warmer than the light side. Scientists now suspect that dark material, possibly blasted from the surface of Phoebe, may have fallen down onto Iapetus long ago. The side that received the dust absorbed more of the sun's energy, and the ice there began to sublimate, leaving behind grains of dust and rock that would darken the surface even further. Meanwhile, the vaporized ice resettled onto the other side of Iapetus and around its poles, creating the look it has today. Even stranger is a long ridge Cassini discovered running along the equator of Iapetus, giving it the appearance of a walnut. In places, the ridge is 13 kilometers high. The forces that created this bizarre feature are not well understood, but it likely happened when Iapetus was spinning more rapidly than it is now, and had more internal heat shaping its surface. Moving even closer towards Saturn, we find Hyperion, a misshapen object with a strange honeycombed surface. Hyperion is so irregular in shape and appearance, it is probably just a fragment from a larger moon that was destroyed in a collision. It may not even be solid, but a loosely packed pile of rubble. Measurements by Cassini reveal Hyperion is more than 40% empty space. Signs of ancient collisions are visible everywhere on Saturn's moons, including Rhea, Dione, and Tethys. At first glance, this trio of round moons could be mistaken for identical triplets. Each one is more than 1,000 kilometers across and carpeted with impact craters from billions of years ago. But they are also variations on a theme. Each of the three has its own distinct features, suggesting a more complex and diverse history. For example, this giant canyon called Ithaca Chasma wraps around Tethys like a waistband. It may have formed long ago, when the icy interior of Tethys froze and expanded, forcing its crust to stretch apart at the seams. Looking at Dione from afar, scientists long wondered about a series of wispy white lines running across its surface. Now Cassini has revealed the lines are the bright faces of steep cliffs formed when Dione was repeatedly fractured by internal forces. But the biggest surprise came from Rhea. Cassini found indirect evidence this moon is surrounded by a dark, dusty ring, making Rhea the only moon anywhere in the solar system with a ring of its own. While most of Saturn's icy moons were likely once geologically active worlds, which later cooled and grew dormant, at least one seems to have forgotten to fall asleep, and the implications are enormous. Enceladus is only 500 kilometers across. Under ordinary circumstances, an object of this size should be too small to retain heat for billions of years. But Enceladus is nowhere near ordinary. Here Cassini spotted vast geysers of water vapor shooting outward from a region near its south pole. The vapor carries fine grains of dust, which escape into space and form a diffuse ring along Enceladus's orbital path around Saturn. Looking down at the surface for clues, Cassini has revealed a strange and puzzling sight. Enceladus is scored with long, deep gouges, nicknamed tiger stripes, from which the geysers are thought to emanate. The stripes are surrounded by fresh ice, which suggests that somewhere below the surface, temperatures are high enough to melt ice and hold liquid water under pressure before venting it into space like a tea kettle. No one yet knows exactly how Enceladus does this. One important clue from Cassini is that Enceladus has more rock and metal than many other of Saturn's moons, and so perhaps it is being warmed by a combination of radioactive heating from within and strong tides produced by Saturn and its other moons. Even more exciting is the presence of organic molecules near the tiger stripes. When this is combined with the likelihood of liquid water, it appears Enceladus may have all the ingredients necessary for life. For a tiny moon at the leading edge of the icy solar system, this is an astonishing revelation. To call the icy moons of Saturn strange is an understatement. These odd little worlds are utterly unlike Earth, but understanding how they formed and evolved is an important goal for scientists. Why? Because if there are so many icy moons in our solar system, there must be countless others out there among the stars. Whenever one of those moons is warmed up enough to melt the ice into water, there exists at least the potential for life. And perhaps our best chance to answer the age-old question, are we alone?